All right, so transcendental means logarithms and exponents. Now, fortunately, one of these is really easy. Okay, I've done the proof for this already. The derivative of e to the x is e to the x. Okay, it's the only function whose derivative is itself. It's pretty crazy. So f of x equals e to the x. F prime of x is e to the x. And the derivative of that is also, it's like, it doesn't matter how many times you take the derivative, it's always e to the x. So that's the first one. Again, I did a proof for that before. The other two I don't have proofs for, I'm sorry. I know you guys love proofs so much and you want to see them, but the second one, the derivative of natural log of absolute value of x is equal to 1 over x. It's technically the same as ln x, like without the absolute value bars. The reason we do that, though, is because you can't take the log of a negative number. So sometimes you'll see it with the absolute value bars there. But it won't matter if x is positive, it's still just 1 over x. And that one's pretty easy to remember, too. It's not a complicated derivative. Derivative of ln of x is 1 over x. I already have it written down there. Okay. So it's pretty much, these two are pretty much the same thing, right? Same derivative. A couple more to look at. Two more, actually. These are a little bit more complicated. The derivative of log base a of x. First one, log base a of x. The derivative of that is 1 over ln a of x. Let me explain that, be more specific. Let's say this was log base 7 of x. So you have a 7 down here. Then the derivative would be 1 over ln 7 times x. The x is on the outside. Here's one thing you got to remember. What if it just says log of x? Okay? Like, let me see. Let me just make a different page here. Does anybody know what the base of that is? X. The base. It's actually 10. When there's no number there, like in the subscript listed, it's 10. Okay? A similar thing happens when you have this. All right, this is a different thing. When you have square root of x, what's the number here? Right, same concept. So when their log doesn't have a base listed, it's 10. Okay? The other thing that I didn't really explain, I don't know if you guys learned this last year. Sounds like you didn't, but ln of x is a short way of writing log base e of x. So the base for ln is e. So if you want to write that down, you can. It's something that pre-cal over here is about to learn in a couple of weeks. Maybe do that. Might do that. If you want to do that, you might just include you guys in it. Is the derivative of a to the x. So let's say it was 2 to the x. The derivative of that is ln 2 times 2 to the x. Okay? If it's 3 to the x, the derivative of that would be ln of 3 times 3 to the x. So those are your 4 rules. First 2 are easy. Derivative of e to the x is itself. The derivative of natural log is 1 over x. The last 2 don't come up as often, but they're still important. Derivative of log a of x is 1 over ln ax. Derivative of a to the x is ln a to the x. So let's do some examples with that, starting with this one. I kind of already said this one verbally. Derivative of 2 to the x. Can you tell me what it is based on those rules? I'll give you a hint. You're going to use this rule down here. All right, first of all, is it in a form that we can understand? Yes, it is, because it has a base and it has an exponent. So the rule we're going to be applying is it's an exponential rule. There's the rule we're going to use, because it's of the form a to the x. Okay? So basically all you have to do is just plug in 2 for a. That's it. All right, it's not asking for the derivative at a specific value. It just wants a derivative formula. So just plug in 2 for a and you're done. So the answer is ln of 2 parentheses times 2 to the x. That's your derivative formula. That's all you have to do. Now, if you wanted to know the slope of the tangent line at a specific number, say 3, then you would plug in 3 for x, and you'd get a number back. It'd be whatever ln of 2 times 2 cubed is, some decimal. But today we're just figuring out the actual formula. All right, so going back to what I was saying about log, I'm glad I brought that example up. Leads to the next example. What is the derivative of log of x? So does anybody remember what number is right here? 10, right? So that's important because that comes up when we apply the formula for the derivative of log. So if you want to, you can just tuck a little 10 down there. That will be end up being your a value. Here's the rule. The derivative of log base a of x, in this case 10, is 1 over ln a times x. So basically you're just writing the rule out and you're plugging in 10 for a. And that's it. That's your derivative. It's 1 over ln of 10, parentheses is important, times x. ln of 10 is just a number, okay? It's probably around 3. So you could think of this derivative as somewhere around 1 over 3x, okay? I know it looks complicated, but this is just a number, ln of 10. It's, like I said, it's around 3. Okay, now we're going to apply the product rule with trig derivatives. So we're going to use both a transcendental derivative and a trig derivative, for example, 3. And we know it's the product rule because it's multiplication sign, so we have two functions. We have our f function over here and our g function over here. So I'm going to go ahead and do that. I'm going to label this f. I'm going to label this g. Who remembers the product rule? I think in these notes, though, I apologize, I think I used a and b. So it'd be a prime b plus ab prime. But I think the reason I did that is because we already have an f here. It doesn't matter, okay? It's the same rule, okay? So there's your product. And just remember, in order to implement the product rule, you have to know the derivatives of both of those functions. So the derivative of ln of x, we already showed was 1 over x. From Friday, when we learned trig derivatives, or Thursday, derivative of tangent is secant squared. Okay, so let's write out this, well, okay, so label a and b, f and g, whatever. So a prime would be 1 over x, b prime would be secant squared, and then you just write out the formula for the product rule, a prime b plus ab prime, plug everything in. This one is, so like I was telling you guys before, like, see how these two functions are completely different? You can't multiply a trig. You can't multiply a log into a trig function. Like, it just stays that way. It's like apples and oranges. I mean, you just don't do it. There's nothing you can do. Same thing over here, except we can actually write this as a fraction. We can write it as 10x over x. So there's your answer. Right, the first one is 10x over x. The second one you can just leave. They don't multiply into each other.